All right, this is for Chemistry CP, a debriefing on this homework assignment, Balanced Chemical Reactions 2, the front side of the homework. A separate assignment is the back side. I might just combine both into this one video. Directions: place the value of the coefficient in each blank space. To do this, I've been humorously calling it a rap sheet, where I list the name of my atom or polyatomic ion. In this case, I can already see there's cyanide and phosphate as polyatomic ions. R is for on the reactant side, the left side of the arrow, and P is for the product side, the right side of the arrow. And what we want to do is adjust by whole numbers. The coefficients, they're implied to be 1 unless we increase them. Adjust the coefficients so that we end up with the same number of each atom on both the reactants and the product side, the same number of each polyatomic ion on both the reactant and product side. So here I go at kind of ludicrous speed. I see I'm starting off with potassium cyanide and silver phosphate to create potassium phosphate and silver cyanide. I would classify this as a double displacement reaction using what we just learned. And tackling this, I see I have 1 potassium on the left. I have 3 on the right, so I might want to bump this up with a coefficient of 3. But that gives me 3 cyanides on the left. So try a coefficient here on the product side, 3 cyanides on the right. That gives me 3 silvers on the right, which is okay because I have 3 silvers on the left. I have 1 phosphate on the left, 1 phosphate on the right. So I'm going to speculate that this is now a balanced chemical reaction. Let's do one final check. 3 potassiums, 3 potassiums, 3 cyanides, which is CN, 3 cyanides. 3 silvers, 3 silvers, 1 phosphate, 1 phosphate. It's balanced with coefficients 3, 1, yields 1, 3. Number 2. Sulfate is always a 2 minus charge. So if I only have 1 copper, this would be copper Roman numeral 2 sulfate. Except I see it's SO3. And I thought sulfate was SO4. So I'm going to go to my handy dandy list of common ions and look up SO3 and see if I screwed up. And sure enough, I did screw up because sulfite is SO3 with a 2 minus charge. Sulfite. So naming this correctly, this is copper 2 sulfite combined with ammonium. ClO2 is called chloride. ClO2 has a 1 minus charge. Chloride yields copper, I'm guessing 2 chloride plus ammonium sulfite. Great. So that's just practice naming these compounds, which you should also do. I also see that this appears to be a double displacement reaction, now that we've learned what that means. And as I work through my rap sheet, I see I have 2 ammoniums on the right, 2 chlorides on the right, but only 1 of each on the left. So let's try a coefficient of 2 on the second reactant. 2 ammoniums, 2 ammoniums, 2 chlorides, 2 chlorides, 1 copper, 1 copper, 1 sulfite, 1 sulfite. This is now a balanced chemical reaction with coefficients 1, 2, 1, 1. Last period, a student asked, what if they got 2, 4, 2, 2? Would that be considered correct? And the answer is no. You are obligated to reduce the whole number coefficients to the lowest common multiple. I don't know what you would call it. Lowest values that are not fractions. So if everything is a factor of 2 greater than what it could be and still be a whole number, divide it by that factor of 2. Number 3, Fe is iron, NO3 is, I want to say nitrate, but let's look it up. NO3 is called nitrate with a 1 minus charge. So because I need 3 of those, this would be iron, Roman numeral 3, nitrate, combined with barium carbonate is CO3, if I'm remembering this fine, yeah, carbonate, to yield, looks like, excuse me, iron 3 carbonate and barium nitrate. This appears to be a double displacement reaction to me. And now let's just get on with balancing it. I have 1 iron on the left, 2 on the right, so let's try doubling that on the left. That gives me 6 nitrates on the left. I only have 2 nitrates on the right, so let's try tripling the ones on the right. But that gives me 3 bariums on the right, so let's try 3 bariums on the left. That gives me 3 carbonates on the left, and I have 3 carbonates on the right. So this might be balanced. Let's do a final check. 2 irons on the left, 2 irons on the right. 6 nitrates on the left, 6 nitrates on the right. 3 bariums on the left, 3 bariums on the right, 3 carbonates on the left, 3 carbonates on the right. This is balanced coefficients 2, 3, yields 1, 3. Number 4. Potassium and ClO is one I don't normally encounter, is called hypochlorite. ClO is hypochlorite. So potassium hypochlorite decomposes into potassium chloride and oxygen. Nice. Well, I can see I need to at least double the oxygens to start off with. And that means I need to double the potassiums on both sides. So my guess is 2 potassiums go to 2 potassiums. 2 chlorides go to 2 chlorides. And 2 oxygens go to 2 oxygens. This is balanced with coefficients 2, yields 2, 1. Number 5. Calcium hydroxide and ammonium arsenate combine to yield calcium phosphate and ammonium hydroxide. So let me just verify the ASO4 is called arsenate, and yes, it's ASO4 with the 3 minus charge is called arsenate. Just practicing naming them, and now practicing identifying what type of reaction this is, I would classify this as a double displacement reaction. Now to balance it, I see I have 3 calciums on the right, so let's start off with 3 calciums on the left. That gives me 6 hydroxides on the left. I only have 1 hydroxide on the right, so let's bump that all the way up to 6. That gives me 6 ammoniums on the right. I only have 3 on the left, so let's double that and make it 3 times 2 is 6 ammoniums on the left. That gives me 2 arsenates on the left. And I think a student sent me an email saying, haha, there is clearly a typographical error in this chemical reaction because I start with arsenate, but it's transformed into phosphate. So hydroxide to hydroxide, ammonium to ammonium, calcium to calcium. So either the arsenate was supposed to be a phosphate or the phosphate was supposed to be an arsenate. Let's do this one here. So arsenate is ASO4 with a 3 minus charge. I need to correct this typographical error. Arsenate with a 3 minus charge, so it's going to be calcium subscript 3, open parentheses, ASO4, close parentheses, subscript 2. So it's strictly a typographical error. Someone wrote PO4 instead of writing ASO4. So the letter P, replace it with the element symbol AS, and the typographical error becomes corrected. Now we can finish balancing the chemical reactions. I have 2 arsenates on the left. I have 2 arsenates on the right. And I believe I just need to do a final check. 3 calciums on the left, 3 calciums on the right. 6 hydroxides on the left, 6 hydroxides on the right. 2 ammoniums on the left, I'm sorry, 2 times 3 is 6 ammoniums on the left, 6 ammoniums on the right, 2 arsenates on the left, 2 arsenates on the right, balanced with coefficients 3, 2 yields 1, 6. And the typographical error. And thanks to the student who sent me an email, I just forgot to make the correction. H2O2 is rocket fuel. It's also called hydrogen peroxide. Hydrogen peroxide, you can buy it in the store as an external disinfectant. Decomposes into water and oxygen. And this is how some rockets power themselves into or through space. To balance this, I see I can only have an even number of oxygens on the left, whereas here, this can be odd or even. So let's start by doubling this to make it an even number of oxygens on the right. 2 plus 2 is 4 oxygens on the right. That means if I double the coefficient of the hydrogen peroxide, I have 4 oxygens on the left. That gives me 4 hydrogens on the left, and sure enough, I have 4 hydrogens on the right. So this balanced decomposition reaction would be 2 hydrogen peroxides decompose into 2 water molecules and 1 oxygen molecule. Since oxygen is diatomic, it's a molecule, not an oxygen atom. I'm looking, we haven't had any individual atoms so far on this sheet. Number 7. Suppose I could zoom in ever so slightly. Says lead for chloride. Was that what ClO was? No, ClO was hypochlorite. Nice. So lead for hypochlorite and lithium permanganate combine to form lead for permanganate and lithium hypochlorite. I classify this as a double displacement reaction. And now to balance it. The hypochlorites stay together as a group, so do the permanganates. So on my rap sheet, I'm not going to break them apart into individual pieces. I'm going to deal with them as polyatomic ions. In that case, I'm starting off with 4 permanganates on the right, so I'm going to try a coefficient of 4 on the second reactant on the left. But that gives me 4 lithiums, so let's make it 4 lithiums on the right. But that gives me 4 hypochlorites on the right, but that's okay because I have 4 hypochlorites on the left. So let's see if it's currently balanced. I have 1 lead, and when I do my check, notice I'm just going left to right across all the reactants. If every reactant is balanced, then I'm done with my check. I don't need to check the products as well. I already did that when I checked the reactants. So 1 lead on the left, 1 lead on the right. 4 hypochlorites on the left, 4 hypochlorites on the right. 4 lithiums on the left, 4 lithiums on the right. 4 permanganates on the left, 4 permanganates on the right. This is a balanced chemical reaction with coefficients 1, 4 yields 1, 4. Notice I'm going at ludicrous speed where if you can't keep up with what a permanganate is, it is on your reference sheet. Here's permanganate. It's MnO4 with a 1 minus charge. Dichromate, permanganate, arsenate, hypochlorite. Clearly, I don't know that one very well. Phosphate, nitrate, carbonate, cyanide. So it doesn't hurt if you memorize these, but I'm not quizzing you at this time on it. Wait till you come back on campus. Sulfate, SO4, is always with a 2 minus charge. And if I need 2 of them to balance this tin, then this must be tin Roman numeral 4 sulfate. Combines with magnesium, I believe that is called chromate. CrO4 is indeed called chromate and it has a 2 minus charge. Yields tin 4 chromate and magnesium sulfate. I classify this as a double displacement reaction. I can leave the polyatomic ions as groups, and I'm starting off seeing that I have 2 sulfates on the left. So let's try 2 sulfates on the right. But that gives me 2 magnesiums on the right. So let's go to 2 magnesiums on the left. But that gives me 2 chromates on the left, which is fine because I have 2 chromates on the right. I have 1 tin on the left. I have 1 tin on the right. Let's do a final check. 1 tin to 1 tin. 2 sulfates to 2 sulfates. 2 magnesiums to 2 magnesiums. 2 chromates to 2 chromates. Number 8 is balanced. Coefficients 1, 2 yields 1, 2. Number 9 is a combustion reaction. These can lead to the highest valued coefficients out of the bunch. And a combustion reaction, there are 2 types we saw last week. One is called complete combustion, where the products are carbon dioxide and water. The flame would be blue if you could see it. And the second type of combustion reaction called incomplete, where the products are carbon and carbon monoxide and I think water, and it shows up as a yellow flame. And the carbon monoxide is, toxic, poisonous, deadly. Okay, so balancing this, the rule of thumb is do the oxygens last. Looking at this, I have 4 carbons on the left, so let's start off with 4 carbons on the right. I have 8 hydrogens on the left, so let's make them 8 hydrogens on the right with a coefficient of 4 in front of the water. Now I have the carbons taken care of, and I have the hydrogens taken care of. The only headache left, oxygen. On the right, I have even numbers of oxygen, only possible with this one. Here, I could end up with the odd number of oxygens if the coefficient were an odd number. Fortunately, this coefficient is an even number. So I think I can complete this one by going 4 times 2 is 8. 8 plus 4 is 12. I have 12 oxygens on the product side. I need 12 oxygens on the reactant side. At the moment, I only have 2. But if I stick a coefficient of 6 in front of that oxygen molecule, 6 times 2 means I will have 12 oxygens on the left, and I think I'm balanced. Let's do a final check. 4 carbons, 4 carbons. 8 hydrogens, 8 hydrogens. 12 oxygens, 8 plus 4 oxygens is 12 oxygens. This combustion reaction is balanced with coefficients 1 plus 6 yields 4 plus 4. Number 10, ammonium dichromate decomposes into whatever that is. I'm going to call that chromium 3 oxide plus nitrogen gas plus liquid water. Okay, well, here the polyatomic ion ammonium is actually broken apart into components, nitrogen and hydroxide, and hydrogen at least. So this one, slightly challenging, huh? I see I have 2 chromiums on the left, 2 chromiums on the right, but let's go with on the nitrogens. I have 2 nitrogens on the left, well, I have 2 nitrogens on the right. I have 8 hydrogens on the left, 4 for each ammonium polyatomic ion, and I have 2 of those polyatomic ions. So 4 times 2 is 8. On the right, I only have 2 hydrogens. So let's put a coefficient of 4 in front of the water molecule to give me 8 hydrogens. Now the dreaded oxygens. On the left, I have 7 oxygens. On the right, I have 3 oxygens plus 4 oxygens. Fortunately for me, 3 plus 4 is equal to 7. And so this is, I claim, a balanced chemical reaction. Let's do a final check. I have 2 nitrogens on the left, 2 nitrogens on the right, 8 hydrogens on the left, 8 hydrogens on the right, 2 chromiums on the left, 2 chromiums on the right, 7 oxygens on the left, 3 plus 4 equals 7 oxygens on the right. This decomposition reaction is balanced with coefficients 1 yields 1, 1, 4. This ends balanced chemical reactions 2 front side homework assignment. Okay, here we no questions on this homework assignment, which was the front side. I see I hid the back side immediately behind the first handout, which means I didn't have to bother printing it off during the 3-minute break. Nice, Mr. Chipper, nice. So this next homework assignment had been to do the back side of this double-sided worksheet, so let's record the debrief on that now. For the following sentence descriptions, you will write the correct formulas and then balance. Number 11, potassium permanganate solid reacts with aqueous iron 3 sulfide to make aqueous potassium sulfide and solid iron 3 permanganate. Yes, this is what you live for as a chemistry student. So potassium, as you know, is K. Permanganate is MN2O4, maybe? This is where you need to have your list of, well, your various reference sheets handy dandy. And I see mine is not handy and it's not dandy either. Have your periodic table handy in case there's anything you don't feel comfortable about. This is one possible sheet, common ions listed by charge. However, there's another sheet I tend to like to use first. I'm going to start off with this one, list of common ions, and let this one guide me as much as I can in writing this down. So permanganate is MnO4 with a -1 charge. MnO4 with a -1 charge. Potassium is always a 1 plus charge, so MnO4 balances. When you write a neutral molecule, you are not showing the charges on it. Some of you have a habit of writing the little pluses and little minuses. You do that before you combine them. But once you write them as a molecule, write it without those. So here it is, solid potassium permanganate reacts with, so plus sign, aqueous iron 3 sulfide. So iron is F3. Sulfur is always a 2 minus charge based on its location on the periodic table, same as oxygen. And the Roman numeral 3 means this iron is a 3 plus charge. So I'm going to have to do crisscross to balance. That means the subscript for the iron becomes the 2, and the subscript for the sulfide, which is sulfur, is a 3. So this is iron 3 sulfide. And it's aqueous, so in parentheses, AQ. To make, so that's an arrow pointing to the right. Aqueous potassium sulfide. Well, potassium is always a 1 plus because it's an alkali metal. Sulfur is always, did I make this wrong? It's, yeah, sulfur, sulfide is always a 2 minus. So I'm going to need 2 potassiums to balance every sulfur. So K2S, it's aqueous, so in parentheses AQ, close parentheses, plus solid iron 3 permanganate. Well, iron permanganate, as we can see here, is always a -1 charge. And iron with a 3 plus charge means I'm going to need 3 permanganates to balance each iron. So required to have open parentheses, MnO4, close parentheses, subscript 3, open parentheses, lowercase letter s for solid. There is the written formula. But wait, it says, and then balance. So again, leaving the polyatomic ions together as a group, I see I have 4 permanganates on the right, only 1 on the left, so let's try a coefficient of 3. That's not going to work, as I can see, because I can only go by 2s for the potassium. So this is why I do my coefficients with pencil instead of pen, huh? I'm going to try doubling this and making it 6 potassium permanganates on the left. That means I'm going to have 2 of these on the right. But that's okay because I see I have 2 irons. So now let's go after the potassiums. 6 on the left, I only have 2 on the right, makes this a coefficient of 3. But that gives me 3 sulfurs on the right, which is okay because I have 3 sulfurs on the left. So let's do a final check. 6 potassiums on the left, 6 potassiums on the right, 6 permanganates on the left, 2 times 3 is 6 permanganates on the right, 2 irons on the left, 2 irons on the right, 3 sulfurs on the left, 3 sulfurs on the right. Number 11 is done. Number 12, aluminum metal reacts with magnesium chloride solid to make aluminum chloride solid and magnesium metal. Aluminum metal just means aluminum, if you like, with a subscript S for solid. Reacts with, that's a plus sign. Magnesium chloride. Magnesium is always a 2 plus because it's an alkaline earth metal. Chlorine is always a -1 because it's a halogen, and therefore you're going to need 2 chlorines for every magnesium. It's in the solid state, so open parentheses subscript S. To make is a yield arrow to the right. Aluminum chloride, well, aluminum is always going to be a 3 plus when it combines covalently with other elements. Chlorine is always a 1 minus, so I'm going to need 3 chlorines for each aluminum atom to make the neutral molecule. And magnesium metal, so just Mg, and if you like, subscript S because it is going to be in the solid state at standard temperature and pressure. So here's my skeleton equation, and now to balance it. Oh my goodness. Looking at the chlorines, I have 2 on the left, 3 on the right. The lowest common multiple is 6. So let's try a coefficient of 3 here, 2 there, 2 for the aluminums, 3 for the magnesiums. I think I'm done. Final check. 2 aluminums on the left, 2 aluminums on the right. 3 magnesiums on the left, 3 magnesiums on the right. 6 chlorines on the left, 6 chlorines on the right. Number 13. Gaseous fluorine reacts with cobalt-3 bromide to make liquid bromide and solid cobalt-3 fluoride. Fluorine is one of the 7 diatomic elements. You can't just write F. It's F subscript 2. And because it's gaseous, of course, it's standard temperature and pressure, little subscript, lowercase letter g, telling the world, yes, you read the word gaseous. Reacts with, that's a plus sign. Cobalt-3 bromide. Cobalt is CO. Bromine is always -1. Roman numeral 3 means I'm going to need 3 bromines to balance that 1 cobalt. To make is an arrow pointing to the right. And by the way, it doesn't even say if it's solid, liquid, or gas, so don't write anything. Let's just skip it. To make liquid bromine, all right, so Br is another one of the 7 diatomic elements. This one's the beer. This one is fear. Beer. Well, it's got to have a subscript 2. And if it's liquid, then open parentheses, lowercase letter L, meaning liquid bromine. And is a plus sign. Solid, cobalt-3 fluoride. Cobalt is CO. Fluorine is a halogen, always a 1 minus charge. I need 3 of them to balance this cobalt-3. So F subscript 3, and then in parentheses, S, meaning it's solid. There is the skeleton equation. And now to balance it, I see I have 2 fluorines on the left, 3 on the right. So let's try a coefficient of 3 on the fluorine reactant, a coefficient of 2 on the cobalt-3 fluoride, on product on the right. Same story with the bromines. I have a 3 and a 2. So let's try a coefficient of 2 on the second reactant and a coefficient of 3 on the first product. And check and see if I hit the desired result. I have 6 fluorines on the left. I have 6 fluorines on the right. I have 2 cobalts on the left. I have 2 cobalts on the right. I have 6 bromines on the left. I have 6 bromines on the right. Done with number 13. Number 14. Zinc metal reacts with aqueous hydrogen sulfate to make zinc sulfate aqueous diatomic hydrogen gas and liquid dihydrogen monoxide. Whoa, what a mouthful. And some of this is, well, it's just water. But zinc metal just means Zn, and it's not one of the 7 diatomic molecules. So when it's by itself, it's just one at a time. Since it's metal, you could put S in parentheses, meaning it's in a solid state, as are most metals at room temperature and pressure. Reacts with aqueous hydrogen sulfate. So plus, sulfate is not sulfide. Sulfate is SO4. 4, in case you don't remember it, go look it up. Sulfate is SO4 with a 2 minus charge. And therefore, for every sulfate polyatomic ion, I'm going to need 2 hydrogens because each hydrogen is only a 1 plus charge. So H2SO4, in parentheses, AQ for aqueous. To make is an arrow pointing to the right. Zinc, by the way, is one of those monotonic cations. Zinc is always strictly a 2 plus charge. Monatomic, no other choices. Zinc, always 2 plus. Sulfate, you might remember, is a 2 minus charge. So one zinc will be content with one sulfate polyatomic ion, no parentheses. In fact, if you write the parentheses, I'll ding you a point for unnecessarily writing parentheses. Because it is aqueous, in parentheses, we'll put AQ. So these parentheses, good, parentheses, unnecessary, bad. Diatomic hydrogen gas, so plus. And it's too bad they went out of their way to tell you that it's diatomic. You're supposed to remember that's half of have no fear of ice cold beer. So it's H2 subscript G in parentheses, diatomic hydrogen gas. But wait, and liquid dihydrogen monoxide, which hopefully you'll recognize as dihydrogen monoxide in the liquid state just means water. So here's the skeleton chemical reaction for number 14. Now let's go balance it. One sulfate on the right, one sulfate on the left, 2 hydrogens on the left, but I have 4 on the right. So let's double this up and make it 4 hydrogens on the left, but that gives me 2 sulfates on the left. So let's double the sulfates on the right, but that gives me 2 zincs on the right. So let's give me 2 zincs on the left and see if it works now. 2 zincs on the left, 2 zincs on the right. 4 hydrogens on the left, 2 plus 2 equals 4 hydrogens on the right. 2 sulfates on the left, 2 sulfates on the right. It's balanced. Number 15. Lead 4 sulfide solid reacts with aqueous ammonium cyanide to create solid lead 4 cyanide and aqueous ammonium sulfide. What could be simpler? So lead is Pb. The Roman numeral 4 means it's in a 4 plus state. Sulfide means just sulfur. And sulfur, like oxygen, is always going to be a 2 minus charge. So I'm going to need 2 of those sulfurs to balance the one lead. So PbS2 is lead 4 sulfide. Notice this is not a 4 here for the lead 4. This is a 2 because each sulfur is already a 2 minus. I need a total of 4 minus coming from the sulfur to cancel the 4 plus coming from the lead. So don't take this Roman numeral and just slap it down there. It would go there if this is always a 1 minus charge, but it's not. This is a 2 minus charge. Negative 2 times 2 is negative 4. So this is PbS2 in parentheses S for solid. Reacts with is a plus sign. Aqueous ammonium cyanide. Well, ammonium, you've almost memorized by now, is NH4 and it always has a 1 plus charge. Cyanide is CN and it always has a 1 minus charge. So one of each is all it takes to cancel and make this a neutral molecule. If it's aqueous, then in parentheses AQ. To create is an arrow pointing to the right. And don't do a dash, don't do a two-way arrow under these conditions, just do an arrow pointing to the right. Solid lead 4 cyanide. Lead is Pb. The Roman numeral 4 means it's a 4 plus charge. Cyanide, Cn, if you need to look it up, always has a 1 minus charge. So I'm going to need 4 cyanides for each lead. That means I must use open parentheses. Cn, carbon, nitrogen, is cyanide. Subscript 4, because I need 4 of these 1 minus charges to cancel the 4 plus charge from this one lead. And since it's solid, let's put that in parentheses. as a subscript. And, plus sign, aqueous ammonium sulfide. Ammonium is NH4 and it always has a 1 plus charge. Sulfide is sulfur and it always has a 2 minus charge. I'm going to need 2 ammoniums, so obligated to have parentheses around the ammonium polyatomic ion, subscript 2, so that I have a 2 plus charge to cancel the 2 minus charge of the sulfur. There is my skeletal chemical reaction. And now to balance it. Well, I see I have 1 ammonium on the left, I have 2 on the right. I also see I have 1 cyanide on the left, but I have 4 on the right. So let's put a coefficient of 4 in front of the ammonium cyanide reactant. That means I'll need a coefficient of 2 in front of the ammonium sulfide product. That gives me 4 ammoniums on both sides. That gives me 4 cyanides on both sides. Side effect, that gives me 2 sulfurs in the products. But as it turns out, I have 2 sulfurs in the reactants. I have 1 lead in the reactant, I have 1 lead in the product. So my claim is this is now a balanced chemical reaction. Let's do a final check. 1 lead on the left, 1 lead on the right. 2 sulfurs on the left, 2 sulfurs on the right. 4 ammonium polyatomic cations on the left. 2 times 2 is 4 ammonium polyatomic cations on the right. 4 cyanide polyatomic anions on the left. 4 cyanide polyatomic anions on the right. This chemical reaction is now balanced.